So the last person is Leonard Speiser. So Leonard is a VC. He founded Neuron.VC, which is the world's first AI-only investment fund. And Leonard has started not one, but 6 other companies before. And the last one, Clover, was sold to First Data Corporation. So he's seen a lot of startups and companies in the space and can give us a very broad view of what the challenges are within machine learning and AI and what the opportunities are. So please join me in welcoming Leonard.
All right, thank you. I am really only a part-time investor. I love building products with engineers, so I always get sucked back in and do that again, even after I've done another startup. But my goal today is I'm recruiting you, not for one of my companies, not for anything I'm working on. I'm recruiting you, join a revolution, okay? Now, when I came to the Valley around 98, I was watching all of these companies try to figure out the internet. We got to add internet to our company. And there was sort of 2 approaches to it. One was, I have a company, it does blank, how can I use the internet? Could I sell products through the internet? How could I add it in? And then there were other companies who said, what's possible that didn't exist until the internet, like until the web was out there? What could I actually build that wasn't possible before the web, right? And so you got companies. I really had to hunt for this US Web logo because I don't even know. Most of you are like, what is US Web? It was a company that like did websites for people, and then like organic and CKS, and a whole bunch of things kind of merged together. But I couldn't even find that logo anymore. But their job was, helping companies build internet presence. And then you had a company like Google who says, I'm going to try to build something that's only possible. And the reason I mention these 2 is because when you start thinking about AI, deep learning, machine learning, you're going to have to kind of choose which approach you want to go. And it's not bad to be on one or the other. Like, think about it. The vast majority of companies use the internet in lots of great ways. You just have to choose which way. And for me, the thing I love doing is I like joining the revolution. I like doing the things that like kind of turn models upside down. And so I'm going to talk a little bit about that today. So first, oh, look at that, the logo. Whoa, cool. I had an AI design these slides for me, but I only trained it on default Microsoft templates, so I apologize for that. No. So I wanted to step back about revolutions. We had the Industrial Revolution, which I actually just call the power tool revolution. And so you think back 200 years ago, and 70% of people in America would be farmers. 70%. So then all of a sudden we have the Industrial Revolution, the power tool revolution, and now, fast forward to today, 3% of Americans are farmers, and yet we're still the largest exporter of food in the world. We're not necessarily the largest creator of food. China surpassed us, but we're the largest exporter of food out there, even though only 3% are doing it. So that's pretty amazing. And what's interesting is that as time went on, we just kept figuring out how to make smarter and smarter power tools. Like electricity comes along, and things are going great. And then all of a sudden, we hit this wall. And the wall we hit was something that VP at Bell Labs called the tyranny of numbers. So all of a sudden, you had electronics, but you'd always have to wire them up. So if you had 10 things, you had to wire up 10 wires. Well, imagine your phone today. Your phone has 2 billion connections in it. So imagine wiring up 2 billion sets of wires connecting together. Well, this guy at Bell Labs is like, we're screwed if we don't solve this thing. We'll never have more than 10, 20, 30. We're not going to get to 1,000. Along come a couple guys who developed the microchip, and all of a sudden we break through this tyranny of numbers. The tyranny of numbers was essentially there's too many wires, we can't solve the problem, and that was a humongous breakthrough, which then allowed pretty much everything that pretty much all of our jobs today, right, is because of that. All right, so let's keep going with tools. So now we have these tools, and now they're even more sophisticated. They're computers and software, but they still only get us so far. Right? So if you think about it, 90% of the work out there today isn't really using computers and software. Or maybe the back office is, or maybe some of the information we use. But the vast majority of work out there is still super intensive, like labor intensive, physical, using your eyes, using your judgment. And so really, we actually don't have technology in most places. Why? All right. Real autonomy, like actually having something be autonomous, it's not the same as building a tool. Building a tool means it just has to do one thing well, and you're really relying on the human to use that tool. Great. Building autonomy means it has to actually start interpreting all the results, and there are a lot of possibilities. This is I was testing an app out, and a friend of mine was at my place, and I was just taking pictures. I took this one, and I had to keep this one because, now every time I see him, I tell him, AI thinks he's a close-up of a horse, and the reality is it's super hard, right? Like if you're a traditional product manager trying to figure out how to spec a product that says, look at this image and figure out what it is, it's really hard. There's too many inputs, right? And so you literally couldn't have. There's not enough engineers in the world that could write enough if-then statements to essentially do that. And so what I call is I'm stealing a little bit from the Bell Labs quote of the tyranny of numbers. I'm calling it the tyranny of inputs, right? There's just too many inputs, and most of these jobs have so many inputs, whether it's vision, whether it's decision making, that there's too many. You can't write the number of if-then statements. It's too much. So we oftentimes like to say, well, let's do the 80% case, and then we'll do the edge. These are the edge cases. Everything's an edge case, when you have all these decisions. So how do you build a product like that? All right. So when we think about autonomy, we typically kind of break it down into these sort of three categories, and I'm oversimplifying to some extent, but when you think about AI, when people say I'm using AI, they usually are trying to apply it in one of these three categories. So something's listening to you or understanding you. Hey, Alexa, list the songs in Moana. Playing songs from Moana. No, Alexa, list the songs. It's like that interpretation. Is it understanding what you're saying? And stop buying Moana CDs for me on Amazon. I didn't ask you to. There's looking, right? Vision. Being able to see. We saw examples. What's in the image? Is that a kitchen? Is it not a kitchen? Is it a bed? What is it? There's the decision process. What should I do? Okay, I'm playing this game of Go or Atari or so forth, and what should my next move be? Or I'm looking at this feed of information. Is this guy hacking me or not hacking me? Is he a good guy or a bad guy? And then the last piece to it is probably the least sort of well-known is the actual action, taking an action. It can be a digital action, but usually people think of it like robotics, pick up that coffee cup and move it over there. That actual action of going and picking it up and moving it, that's kind of what we want. That's that doing part. And then it kind of goes back in a circle again. Okay, did I do it? And then should I change my approach? And so it kind of goes in a circle. All right. The challenge is, though, is we read all these articles about AI, and look, I'm super duper bullish on it. I'm recruiting you for the revolution, but I also want to prepare you. Computer vision is really what had the recent breakthrough, right? The examples you gave of Feifei's lab, and then computer processing, and we saw Google Photos all of a sudden could see everything in your photos, and that had a really remarkable breakthrough, and that is actually where we're seeing the majority of interesting things right now that are really working. The other areas are all super exciting, and there are some breakthroughs happening, but nothing on the order of what we saw in vision. And so we're going to get to all of these. And this sort of, the wheels are turning now. We're going to build them. But just keep in mind also as you're building products that sometimes you need some of those breakthroughs before you can really have the tools to build everything you want. And so be careful how you kind of get sucked into that. Vision is the one I was mentioning that I think is by far the furthest along. And again, if someone here knows of other areas that are really far along, I'd love to learn about them. But when I've invested in companies or started my own in the last 2 years of sort of focusing on this area exclusively, what I found is vision seems to be very doable. That said, there are different approaches to it. And I didn't know sort of the level of technical in the audience. And for those who are really technical, I'm going to be wrong. And for those who aren't so technical, I'm going to be confusing. But these are a couple categories of companies that are tackling a space that I've invested in. And so example is, is that a dump truck or a cement truck there, at the site? And that's, people oftentimes use the term convolutional neural net, right? So that one we use convolutional neural nets for because essentially it's good at classification, like you saw with picking, is it a kitchen or not a kitchen? But when did it arrive and how long did it sit idle? Well, convolutional neural nets will get there, and there's some other things besides that for neural nets getting there. But you can also still use some tools that have been out for a while for those problems. And oftentimes people use something called OpenCV, which is just stick a bounding box around the thing and see that it's going left or right. And sometimes those tools are still way easier to solve the problem. So sometimes you combine those tools together. And in fact, you do that across a lot of these categories, actually. You'll use convolutional neural nets for what they're good at, and then you might use something like OpenCV, which really isn't the thing that people are most excited about recently, but is a phenomenal tool that still gets you part of the way there. Transportation, is that a loading dock? Is that car running a red light, right? So oftentimes you see this sort of theme of like motion versus identification. Company that I invested in that looks at people in physical spaces and retail sales, how many people visited that area of the store versus how old were they, right? So sort of identifying what's in there or what they're doing. And there are more tools than this, but just to give you a flavor. Okay, even with this though, all these companies run into problems. And so what are the problems you run into? I mean, even with this, it's not like they just like cranked the product out and just started working. They keep running into problems. And again, you have to solve the entire class of problems. You can't just throw an if-then statement to solve it. So all of a sudden, a truck backs into the work site, but you've never really trained it on a truck going backwards into the work site. You always trained it on the truck going forward into the work site. So you are actually now miscalculating whether the guy's going or coming anymore, right? So is there a solution to it? Of course. And you're probably already in your brains thinking about the different solutions to it. Your software thinks that a reflection of an object in a mirror or something nearby is the object, right? You're like, damn, why didn't I spec that? No reflections in my identification. And then a person turns your head one way, turns their head one way, turns their head the other way, and your thing's going, oh, that's a different person. That's person A, and oh, nope, now it's person B. They're definitely different. They don't look the same. So these are still problems that are running into, you sort of thinking about how do you solve it. You solve it not with the if-then statements, but you have to still then come up with maybe other algorithms you can use and additional training data you can use. So, all right, maybe now I combine the direction the truck is pointing with the trajectory it's moving. So and then I use that as a solution for lots of things. Maybe now I don't have to just use it for trucks. Maybe I can use it for workers and which way they're going. I'm going to train that software to understand the difference between what is a floor and a wall, and sort of understand the context of the two, and say, well, if the image looks like it's up here on the wall, it might be in a mirror, not in the subject. And that example of the person walking around, maybe I have to now generate a path and grab several frames and then essentially sort of say, what's the similarity between these? All of these of which can be extremely computationally intensive at the same time, so you have to make really hard decisions whether it's worth it. Do you do it on the edge? But these were all actual solutions to these problems. These are companies that had to solve these problems, and they did solve it. Okay, what's the good news on this? The good news is that these companies are actually doing really well winning pilots with their customers out there. So you're dealing with a whole slew of industries out there who've never had software really at the core of it. You go to the construction site, you're not watching a ton of software doing stuff all day long at the construction site. You're not seeing a lot of computers at the construction site. And so on and so forth with most of these industries. So you go in, you make a phone call to these industries, and they've never had anyone pitch them these kinds of things before, so they're eager, they're excited by it. And so they are, and there's not that many people doing it. So they love the fact that there's not too much competition right now, so it gives them opportunity. They like the consistency from the customer perspective, likes consistency. Last thing though is, we're not seeing like $1 billion of revenue flowing into this area yet. It's still early days. And so that's something just to keep in mind. Fun, interesting problems, but you're not seeing multi-billion-dollar companies yet. I wanted to mention one thing because I knew there was a lot of folks from the product side here. Building products in this area, which you kind of heard, isn't like your traditional like I spec the product out and then and then I build it. You don't know if it's going to work. We heard that a few times. So it looks a lot more like I pulled up the old you're in grade school or high school and you had to do your experiment. It kind of looks more like that. Like it's not going to be agile. It's going to be like experimental in nature. You might have to throw your approach away. There are times where you go 2 months working on something and you're like, that didn't work, and I can't even use any of it. It's garbage, and you throw it out. Super frustrating, really hard to plan for both a startup that could run out of money and even in a big company where you have a lot of expectations and people are always, priding themselves on hitting deadlines. And then the training time can take as much time as the code. Like you might spend 3 days coming up with the algorithm, writing the software, And then you could spend months sitting there training and trying to figure out what's going on. And then the last thing we talked about, I already talked about is you're not even sure if it's possible. You're basically running an experiment. Okay, that said, super exciting still. Like 90% of the industry's out there. So I kind of want you to envision that picture I had at the beginning. Transport yourself back to medieval times and think about how crazy it would feel to be back then and how it feels today. Like now, do that going forward and imagine the other 90% of the work out there that could be being done at an order, a scale that's incredible, where you never have to clean your home anymore and you never have to make your food anymore, and a house can just be built, and it's going to be a tremendously different world. And then again, remember that we're at that point where you kind of have to decide, similar to what I was having to think about with when I came out here, was do I stay in packaged software, like a la where Microsoft was the dominant, you're going to crush everyone. I used to be told that all the time when I was starting companies back then. And then all of a sudden no one's talking about Microsoft anymore, and Google comes out and they weren't even thinking about that. And remember that almost all of us are in tools companies today. Most of us are building a power tool, right? Or just something that gives a human sort of an extension of themselves, but you're not actually yet building something autonomous. And that's really the revolution. And I really hope you guys think about where you want to be over the next 10 years, which part of that equation you want to be in. There's no right or wrong answer. You choose the way you want to go. But the autonomous revolution is going to be really exciting. The things that we're going to build are going to be exciting. That's it.